So if you're having any issues with any sort of installation or any libraries or anything is not working, RStudio Cloud is the easiest way to get it to work, like temporarily. It may not really work on a long-term frame, but on a short-term frame, that's perfect, right? So they give you some free space. So it's RStudio Cloud, right? And you log in whichever like Facebook or Twitter account you have. So it allows you to set up your accounts like really in a second, right? Now the beauty about using RStudio Cloud, it looks after yourself, right? So you won't going to have any version control issues or anything not installing, like libraries not installing, anything not installing. So you definitely, yeah, so they will pick up. So if some libraries that you're trying to run are not installed, they will warn you about it and they will install things for you, right? So I suggest, like, I'm going to show you what Twitter has to offer, but so if you, in like whoever, if you're not able to get access to RStudio Desktop for now, so just use RStudio Cloud.
Yeah.
Right. Now, in terms of social media, so I do have so I do my research in social media. So
Yes.
I've been using Twitter and I've been using Facebook, Instagram, and YouTube.
Yeah.
And out of the whole bunch, I will tell you
Yeah.
that so a couple of years ago, it was not a problem at all to get that access to data. And that's
Yeah.
why when yesterday they asked the question, so where the data was coming from. If it's just a couple of years back, that was not a problem at all. So that data was like really wild west,
Yeah.
and you get access to whichever you want.
Yeah.
But since all these like ethical issues being raised,
Yeah.
we're starting to be more serious about how data is handled. So Facebook particular was very, well, not in relation to their scandals, but in relation to how they change their policy and how they change privacy issues, right?
Yes.
So very particular. Twitter was a bit of a more traditional, a bit of a more conservative on that. And if you look at what is happening now, Twitter is more open for your research. And if
Yeah.
you space, you probably will see more research on Twitter. And this is the question where availability of data
Yeah.
is still there. Well, they're still controlling it, but there are ways. So they're much more open for, especially for academic research.
Yeah.
So the most difficult one to get access to is your Facebook and Instagram. So Facebook and Instagram basically they are the same platform for developer access. So so when I'm using, so whatever data I'm using for my research, I'm always going with developer access. So I never purchase my data from any third parties or anything, right? So I always collect my data myself. Now, it's quite easy to apply for developer access.
Yeah.
Savannah, do you think this conversation will be interesting to others? What do you think?
Yeah, I think I don't know, Maria, because we only have till 3:15, and like I think people are waiting to maybe like people would be looking forward to do some more as well and have those comments like for like to wrap up as because that
Okay,
this is a big subject in itself, isn't it?
Yeah, well, absolutely. And I have like a lot of little tips to share. Like my only question is, I'm not quite sure if we're going to have time to cover the case study for Twitter. So if we don't have that time to cover Twitter, then probably I will leave like 10 to 15 minutes and to share tips on how to get data on social media, because application side, like you've got all the methodology, right? So you've got all the beautiful packages, but the key point is where you're going to apply for, where is your data coming from, how to get it, because this is like how you do things is there. Where are the things? That's the problem, right? So, but yeah, so Samantha, if you can remind me, like probably 15 to 20 minutes before we end up. So we're going to get me good grab of time. So we have to wrap up at 3:15 or like what's the
3:15,
time?
yeah.
So
I think
3:15.
it is
So
3:15. Let me check.
if you can just check it.
It is 3:15, Maria.
Yeah.
It's like it's
It's
right.
3:15,
So
Maria.
3:15. So if let's say like we are going to set aside like 20 minutes time, because like that example that I'm going to show is quite interesting. I don't really want to like because Tanjim, again, so you can get your data, but you need to know how to apply. So Sivan, if you can remind me at like at 2:50, 2:55.
Yeah.
So we can just move on. Like, I will just try to organize my time. But anyway, so we may not really have time to finish off with that Twitter example, but at least like you've got some knowledge, some tips on how you do things. Right, so
Okay.
I've done application for all of them. So think about like I've done it for Facebook and Instagram, where you have to go through the application process. Now I've got some issues with your YouTube, who like that was amazing. So I did my user R, and my my presentation was on record on the YouTube, right? And they picked up that presentation, they picked up that video, and they banned it. And they banned it just because like I was like showing how to set up YouTube access there. All right, so there's some issues there. So again, but I'm going to talk about those things at the end of the presentation, right? So we are all back and ready. So let's roll in. So the first part of the tutorial, we'll look at the visualization capabilities available there. And again, so hopefully you got a chance to compare the classical way of doing visualization, data visualization, with all the new developments happening in the area. So hopefully you are all absolutely amazed by the ggraph library that offers so much opportunity for you to communicate with your data, not just to present it, but to communicate the message. So in any way, so we're moving on, and now we are going to have a look at a different library, tidy graph library, right? And right, so tidy graph library. But before that, let's refresh on some of the graph theory questions. I'm not going to go into too much detail, so you stop me if you already very familiar with this, but it's just like I want to mention those details in relation to implementation in R that we'll be using. So we are going to work to have a look at some major fundamental concepts. So graph measures. So whatever graph you have, probably the question that you may ask, how complex is the graph? How big is the graph? Who are the main actors? What are important parts of your graph? That becomes really important when you start visualizing it and see, like, do I really need everything for the message that you are trying to convey? So so let's start with basics. So what's the size? What's the size of the graph? We're looking at number of members. So usually we'll look at nodes, but we also can sometimes some books refers to edges, right? Now let's have a look. We're looking at, so I'm gonna have all the, all the Zoom things here. Now, we may think about density, and that's the proportion of observed ties of the network to the maximum number of possible ties, right? So we've got that complete graph yesterday. So for a complete graph yesterday, the density will be 1. Right, so all the nodes are connected. Guys, unmute yourself. So let's let's make it a like conversation, because talking to myself doesn't really look nice. So size, how many members you've got, nodes. Density is what's the proportion of those connected members to not connected members, right? Diameter, we're looking at the maximum shortest distance between all node pairs in the graph, right? And we also have, like, in every other library, iGraph or StatNet, you always have function that allows you to calculate that. Even tidy graph, they have those inbuilt functions, which is like standard. Right, now let's move further. So node measures. So node measures centrality. So centrality is the way, this is the measure that we use when we ask a question. Who is the most important one in the network? Why would you want to ask that question? This is a good area, right? So this is where we start to differentiate different measures of centrality. All right, so usually we'll look at the influence and the influence that particular node or that particular actor has in relation to the network. All right, so usually that's the position in the network that they have, and that depends on the graph. So you may have different types of graph. At the same time, you may have connected so how I'm just getting a bit tired. Right, so it depends on the type of the network that you have. If we're talking about social network, that will be the influencer. If we're who we need to contact to get our mass to get the most effect on the community. Now it may be the key train station in the urban network that we looked at yesterday. Centrality, when we talk about centrality, we have different measures of centrality. So the most common one will be degree centrality. And this is where the number, where we think about that as the number of edges that a node has, which is the number of links incident upon a node. So we've got a node and how many links are going out of there. Now we also have eigencentrality, which is the measure of the importance of a node in a network. All right. So what are we doing? How are we getting that measure? We are assigning relative scores to all nodes in the network that connects to high scoring nodes attributable to the node in the question. All right. And the higher the eigenvalue centrality you have, then the more connected that node is to high degree nodes. Right, so if you're trying to isolate who is going to have the most effect on the most important node, that's the eigencentrality that you may have. All right, now, so I am putting it here. All right, so different types of centrality. Now, let me think about, so do we, I think we missed closeness centrality. All right, so closeness centrality measures how many steps is required to access every other node from the given node, and it describes the distance of a node to other nodes. All right, so the more central the node is, the closer it is to all other nodes. All right, and we also will be using, so not now, but later in the case study, we will be using authority centrality or hub centrality. So it's generalization of our eigenvector centrality. And when we have a high hub node point that receives so a high hub node points to many good authorities, and high authority node receives from many good hubs. All right, so we'll be using that later when we go through the case study to demonstrate that. Now let me yeah, so I've got them here. All right, I was just where I put them. Right, so at the stage we've got lots of different measures of centrality and lots of different ways how this can be calculated. Now, how do we know which one to use? And for this one, we've got a very fantastic package, which is called Central Informative Nodes in Network Analysis package. So we see now, right? So it's in CRAN, and I suggest that you have a play with that. So let's pull it up here. Oh, that's not the one. All right. So this is the package that we're going to use. So this package is real cool because it allows you to compute the different centrality measures. So let's have a look. So I suggest that you try it, and we're going to try it at on our Zakaric lab. So do you remember Zakaric Karate lab? So we looked at that yesterday, right? So let's have a look how it's gonna work in our case. So what I suggest doing, so with this package, it's a separate package. I suggest that you install it first. So you go and you do installation packages. Oh, I think I missed the first one. Yeah, Daniel, you're right. So yeah, so clarification. So closeness is the average distance to all other nodes. And when we look at betweenness centrality, we'll look at the number of shortest paths between all pairs of nodes each node falls on. All right. So let's move on and have a look how we apply those different measures of centrality. So can you install that package? Yeah. And now if we put it as a library, and we'll load our data. Guys, can you just give me a minute because I've got somebody like ringing. Just give me a second. Just yeah, that was like the postman. Like these days, postman is the most important person in the whole universe. All right. So let's have a look. So it's all so it's installed, right? So library is loaded, and now let's do the data. So that's our Zakari club. So if you remember, so what's the Zakari club? So there was an issue with the karate members, and they got a conflict. And that data is about some interaction happening between those members. So if we just plot it, right? So this is where we're not getting fancy. We're just plotting it with our normal eye graph. All right, so let's plot it over there. So that's our graph. So let's have a quick look at that. All right. And let's move further. Now, that package has a fantastic function that allows you to have access to 43 most popular centrality measures that can happen. Right? So the function proper centralities allows you to actually see the list of all the different measures that can be used. Right? So let's try and do this. Right, so and you should see 43 different options that can be used. Well, it's growing. All right. Now let's move further. So out of those measures, 49, Michael is saying. So out of 49 measures, which measure is the measure? All right. Are we going to take all of them? So if we are going to if you're going to spend your your PhD on just doing all different measures, that's perfect, right? But think about just with complex data sets, with big data sets, just calculating that can take time, right? Just calculating one can take time. So calculating all of them may be like a very very difficult question. Now let's have a look what we can do. So if that's the case, let's have a look. One of the suggested ways for you to work with this and detect which centrality will have more information about that central nodes. So this is the question. So how do we know which measure to apply? How do we know which measure to use? So have a look what you can do. So the idea of using centrality is to identify influential nodes in a network, and the more accurate we go, the better. All right. So how we do that? So let's have a look. So in this case, we can use our PCA. So old classic PCA and compare those measures. So let's have a look. So again, I'm not going to go through all of them. I don't really think that you should go, but let's use calculate centralities from the package, and let's include only the first 5 methods for us to compare, right? So the first 5. So this is what we're doing. So we're calculating measures, and then we're putting it through PCA, right? And we're trying to just put it here. So I'm going to copy it in a chat. So for us to see which measure is the measure. So we're not going to go through the whole PCA, but that representation gives you some ideas which measure you should be using. What do you think? I do have my answer here, but what do you think? So we need to use the one which has the most contribution value if you compare all 5. So in this case, we're just sticking with 5. You can include more, right? So you can include 49, but it will take ages and ages and ages to be able to get your results, right? But again, so the idea is the same. So you probably have your domain knowledge, and you may know which measure of centrality may be the best one for you to use. But again, so this is one of the ways how this can be identified. Right, so in our case, we're going to barycenter centrality, right? And that's what we can use. So again, this is to demonstrate not only that can be done, so the different measures of centrality exist, but that because we have like lots of different R tools that can be used additionally to all those main packages. So I suggest, so whenever you start exploring new things, and it's really, those new things, they appear like daily. All the new packages are the development's happening so quickly, and the community is so active that you really need to keep your eyes open on what is happening. And if you have a particular problem that you are struggling, it may be that somebody else is struggling with this exactly the same problem and already putting a package. Now, I want to draw your attention that on CRAN, so if you've got any issue, so CRAN has task views, right? So task views that I encourage you to use. So the majority, I think the majority of our package goes under graphics, right? But it sometimes they go under domain areas. So you may dig into your domain area and see what other task views are available. Those task views are updated on a regular basis. And apart from that, our consortium is regularly putting some grants for development of packages and development of some documentation around existing classification of packages. So if you believe that there is a really big gap that you want to fulfill and develop your own package, you are more than welcome to do so. All right, so we're talking about our consortium grants. And I think that they've got a call for proposal happening, if not now, then quite soon, right? So that may be the area where you want to apply if you're thinking about that existing packages may not really be enough. Right? So this is where you may have a look. So again, but you need to make sure that it's really, there is a niche for that. Right? Now let's go back and let's have a look at further. So let's visualize our graph. So we know that centrality type what we're going to use now because it has, like, again, the highest contribution, right? And so we are putting visualize graph, and it's part of the, so it's not part of the G graph, it's part of that CNAP package, right? So if you can run that. Right? So we are using visualize graph with the centrality type which we selected. And if you look at that, so the node size indicates the centrality value. Right? So what do you think? So my first question, were you able to run those lines? Oh, so we need to wait. So it's
well, Maria, I couldn't run the previous line because my broom was outdated. I need to reinstall my broom, and
okay.
yeah, so yeah, so the second one, the plotting, yes, but not the previous one.
So, but yeah, but well, we solved this for you. So it's the same as a Caddy Club. So it's the same data, it's the same graph. So it's basically the same centrality measure. So for that graph, that's the very centrality, which is the most like critical one, right? So it looks quite small just because I've got like some slides here, and this is the culprit when you've got when you've got slides to present. So it looks quite small, but you should be able to zoom in on your plot so that you're able to see that. Right. So if you're having issues, so have a look. 6am have a really good suggestion. So if somebody is not able to run the previous line just because of outdated libraries, so they're just saying that restart your session. All right, so restart it's a really good question. It's a really good suggestion to any possible problem. So if something is not really working or like looking quite different, right? So restart your R. We used to be on that, like, press that reboot button. Well, I wouldn't really dare to press my reboot button because I have so many other things running, right? So that will ruin like a whole 6 months of my work. I have to do that, but yeah. So restart your R. So if you are in your R Studio, right? So somewhere here. So we go to your session and we go to restart R. Right? And it usually clears. Sometimes my R behaves like really strangely, and that sort of set it back to where it has to be. Right? Right, so now let me have a look. So looks like, yeah, so we're moving on, right? So people like in the chat are moving on. So let's go further. Right? So that's part of so let's move further. Now we're going to go with again, so some basic things like so subgraphs and components. So what are those? And they're not particularly to R, they're like just general knowledge about graphs. So subgraphs are subset of nodes and network, and we're looking at edges linking those nodes. So if you look at this graph over here, then what do you see? We've got, so if you look at nodes, we've got nodes 4, 5, 6, and 7, right? And they look like as a subgraph of G. Right, we can also have components, which is a subgraph of the network that is disconnected from the other one. So this part, so if you look at these ones, so these ones are connected and these ones are disconnected. So we've got two different substructures, right? So again, it may be quite important depending on what exactly you're trying to isolate in your research. So if communities are totally disconnected, then it may be something like you have your action plan to remedy that, right? Yeah, let's move further. Right, so we've got some other measures. Again, they're not really related to R, but they are like universal. We already looked at community detection when we looked at clustering. Right, so a couple of people mentioned like different algorithms we can use. Absolutely fine. Right, we're going with this most simple one, like the most accessible one, but there are definitely others. So we're looking at number of algorithms to detect groups that consist of densely connected nodes and have fewer connections across groups. So if you're familiar with clustering techniques, when you're trying to maximize that betweenness and like outness, right? So that's part of this. Now we also have homophily, which is a tendency of nodes to connect to others that have that is similar to on some variables. And again, this is a very, very big area of research, and I wouldn't really dare just to like just do a lot of stuff in the last 1 hour that we have left. All right. Now let's move further. And let's have a closer look at the tidy graph package. So looking at the tidy graph package, we are going to use some of those measures to complete a short case study, right? Now, but let me give you an example, like explain why tidy graph is so good. So if you remember, at the very start of the session, I mentioned that the best thing about using R these days is that you have that tidy data approach, and you've got a tidy data concept. Now, while that tidy data is quite easily applicable to the normal data that you have and the normal data workflow that you have, it is quite challenging to apply it to graphs, right? Just because you've got like very, very non-linear, well, not that flat structure. So how can you apply something which sort of has to be flat to something which is not flat? And this is where they devised a tidy framework that can be applicable specifically to graph networks and trees. So the idea behind that tidy graph approach or tidy data approach in relation to graph is that we have two tables. So we've got one table with the node data, and another table is with the edge data, right? So you can create your graph in such a way that your data will be stored in these two data tables. And the beauty of storing the data in the data table is that you can bring one data table into focus and then switch your focus to the other one when you need to. And while you do this, so if you switch your focus to one of the data tables, you are able to apply all the tidyverse, all the dplyr manipulations in relation to that data frame. Does that make sense? So you basically ignore that your data is not really flat, right? So, and you work with only with the data table, which you currently has your focus on. So let's have a look how we're gonna do this. Now, to be able to go any further, so first, let's load our library. So you need to have tidyverse, all right? So again, so if you restarted your R, then any sort of like, just changing. So make sure that you have your library tidyverse. You also need that new library which we are yet to work with, tidygraph, right? And we're going to work with ggraph. So usually ggraph and tidygraph, they usually work together because it's such a next step on using, all the R tools over there, right? So I also have my sample data set, which comes, so again, so I'm showing you all the different ways how the data can come from. So we were looking at CSV files, we were looking at some repositories, and now, so this is another data set, and hopefully I will have time to show you a very, very big collection of data sets. It's called network data. So if you want to have some practice in using your graphs, that package is absolutely fantastic. So let's start with the first thing. So load your libraries first. All right. So I'm posting those libraries in the chat just in case you are sort of restarted your R, rebooted your computer, or done something. All right. So can you just make sure that you have them? And now, so I have a look. I'm going to use one of the repositories with data. Now, so what you need to know, we need to know that for data sets, so some data sets are available as part of libraries. Now, if the library has some functions, all right, so if the package has some functions, then it can be registered on CRAN. And this is the case where you do have some inbuilt libraries. For example, tidyverse has loads of inbuilt libraries, right? So iGraph has some inbuilt libraries. But if you have a package which doesn't include any functions, but include only data sets, then unfortunately it cannot be registered on CRAN, right? So one of those data sets is what we have here, right? So navigation data. And to be able to install it, you need to go and use DevTools. Or alternative for that will be to use CRAN, right? So let me copy that line. Oops. And let's put it here. All right. While you're doing this, so while you're going through this, let me show you another fantastic package. Would just work with the data, with network data. All right. This is a really, really, really good data set, and it's an aggregator of lots of other data sets. Now, give me a second. You need to give you the main one. So if you are thinking about digging down the network science using R, and if you're looking at some resources, this is like really fantastic. Now that data set, have a look. Well, it's a package basically. It's a package which includes only data sets. It doesn't have any functions, but it gives you such a big flexibility, right? So it includes nearly 1,000 data sets with, have a look. That's the treasure, right? So again, so it, like, very unfortunately, it will never get listed on CRAN. So you need to install it, or sort of semi-manually, right? So you need to install it using DevTools, install GitHub.
Well, Maria, just to double check, so this is network data from stochastics. So this is a different. So would
this
you
is I'm just showing you all the options, right?
Yeah.
So I'm just waiting for people to get installed, and so that we're not losing time, I'm just giving you alternative options for you to dig into network science further. Usually the problem is that you do have instrumentarium, you do have method, you do have packages, but you're missing your data. So where you're going to apply. So what is like, again, so this is what Tanjim, so we were talking about. What's the problem to which you're going to apply your all the fancy methods that you've got. And so here is another option for you to use. So yeah, just empty cast is not going to cut it, right? So empty cast is like a really popular data set from tidyverse, which has been used in every single example. So if that's not your, like you want something else, you want a more complicated examples, these are the examples, or these are the data samples for you to use. At this stage, we're just sticking with very simple data set, right? Just to show us how we can use tidy graph. So hopefully you were able to load your libraries, and hopefully you were able to install that data set, right? So you go, right? So you use your DevTools, all right, Jiang. Yeah. So if you don't have your DevTools installed, so you need to install packages DevTools. And then we reference install, so DevTools, right? So have a look. So we use DevTools, so we reference the package, right? Then we use semicolon, and then we specify the command that we've got. So in this case, that's the name, that's the username from the GitHub, and that's the repository name. All right. Yep, thank you, Norman, for yeah. So if you've got some issues installing it, so you need to put one more parameter, one more option. Use force set to true to force your installation. All right. So let me know when we can move further. So that's also that's only the setup. Charles, where are you? It looks like really, really dark over there. It looks like you are in a different time zone. I'm just looking at all the participants. Right? Ooh, Charles, that's so nice. Good morning to you. All right. So can we, do you think we need to wait more, or should we move on?
Maria, let's move on. Yeah.
Yes, let's move on. So we're going to use, so once you have your data, right? So we are going to create our object. Now, we've got two fantastic functions. So you remember, like every package we go into, we do have another function to create objects. Now, in this case, so have a look. This is a special one, right? So table graph. And the table is the data type which they use in tidyverse, and this is where they try to translate that in relation to tidy graph, right? So table graph. Now, some people asked about conversion between different types of formats, right? So like there was a question yesterday. So we were looking at iGraph and we're looking at StatNet, because those packages are quite classic. So they to convert from one object to another one, you need an extra package which is called Intergraph. All right, so if you need that information, just bug me and I will be able to send it to you. Now, in this case, have a look. We're going to use table graph, right? So it creates a network object from nodes and edges data, right? If we need to convert it, we use as table graph. So this is much simpler than it used to be. So you don't need to have any other extra package. You just use as table graph, and it converts your data from like very long list of other objects, right? So now let's have a look. So let's actually create it. So let's move further. So first, so this is like a phone call data which we're going to use, and this is from the package which you installed, right? So what are we doing? So let's make it available to us. All right. So this is our data that we're going to use. And now in that data, so let's say we're going to create our table graph. So for table graph, and then we specify our nodes, right? We specify our edges, and we say that we want to have it directed. All right, so let's copy it over. So that table graph, again, as I told you, it has two data tables, one with nodes and one with edges. So, and the whole idea of working in tidy graph is that you switch between, so you make it like a, you've got a spotlight in Zoom. That's the same thing as you have in tidy graph. So you need to bring one of the tables to a spotlight, and all the operations, all the steps will be done on the data table, which is currently in a spotlight. All right. So at this stage, we just created the object. All right. Now let's have a look. So can we, we're moving further, and let's have a look. So we are, so let's do the very first thing. So let's use our very familiar, very lovely G graph, and let's put it on as an individual form. Right. So we are saying that I want to use G graph. So I'm setting the first layer where I'm setting the data layer. So I'm saying that I'm going to use my graph object, and this is like the layout. So we're sticking with graph opt, right? So that's the first layer, so data layer. Then we're adding up another layer when we're specifying our how we want to show our edges. So we're specifying width, and we're specifying the color. Right, so for color choices, well, it's a good question. So how you can get your colors? So I usually use so you can stick with hexamals, right? Or you hex numbers, or you can just go with colors. So if you run a color command in R, you can get the list of all the possible colors that they have. If you want to get a hex number, then W3 schools have really good color picker, which allows you to generate that hex number for you, right? If somebody needs help how to get colors, happy to show that, right? But at this stage, just like that. So usually color choices are the option. So we're setting our edges. Now we are setting our node points, right? So that's the same, we were playing with that before the break. And now let's have a look at our labels, right? So for our label, so for our node text, we need to refer to aesthetics. So I really want you to remember this, right? So whatever comes from your data needs to be mapped under aesthetics, right? So here you don't really need to use any aesthetics, because unless you want to relate color to any particular attribute or any other particular feature or filtering in your data. So if it's straightforward, just set it for the whole like all data points, then you just use this. But if you want to relate it to any particular label or any particular variable that comes from the data, this is where you need to use aesthetics, right? And so we're applying the theme. So, and this is like our very straightforward graph. All right, so let me put in the chat. All right, so you let me know when you're done. All right, perfect. Now let's move further. All right, let's move further. Let me playing with zoom around is just like the whole next level of complexity. All right, so this was a very straightforward example when we apply graph. Now let's do a little bit more complicated things using all the functionality of graph and tidy graph. Right, so this is like we just created an object and that's it. So like it's there. Now let's have a look at our very familiar empty cars, and let's think about how we can work with empty cars in a graph format. Right, so we're going to use empty cars dataset. So if you don't know, this is a very popular dataset which comes from the tidyverse package. It's like used for every single example, doesn't matter which help file you're going to get. For every single case where they try to show you all the functionality available in their functions. So I'm picking this up just to show you that all the functions relevant to tidyverse will be relevant to tidy graph as well. Right? So what are we going to do? We're going to look at correlations, right? And we're going to do a couple of changes in our data set. So we're going to apply the correlation function, and for the correlation function, we're going to use a new package. So I'm like as I told you, there will be a few smaller packages which you will need to install, and that's package correlation. I really love that package because it allows you to work quite easily. Oh yeah, sorry, but yeah, so it's extra line here, extra quote here. It's a typo in slides. I need to fix that. All right, so it allows you to easily work with your correlation tables and present your correlation table in a nicer way. For example, if you've got some extra bits in there, you can remove it. So I really love the package. And another like really good package for working and presenting the data is a Stargazer. Really love that one. All right, but let's do one step at a time. So first, we're doing the correlation to be able to get our empty cars to convert it into the format which we can use later for our graphs to see the connection. Remember, the whole thing about using networks is connection between those nodes, those objects. Right, so let's install the package. So let's move it. Let me copy it in the line. So I already have it installed. And let me fix that extra quotation. Yeah. All right. So I'm not going to go into all the details of my changes that I'm doing here. All right, but yeah, so just to wrap up quickly, we may be running out of time. So I am computing the correlation matrix, and then I convert the upper triangle to an ace using my shape function. I don't really need them. And then I stretch the correlation data frame into a longer format, so I can keep on, and then I keep on the high correlations. All right, so I've got all these steps set up here. All right, so let me copy it into the chat. So again, we're doing some data preparation. It's not yet tidy graph. All right, so we are preparing our data. Now we're saving our change the sort of the data in so it just, well, yeah, so thank you Sixian. So this is just in case if you've got, so those are can you make sure that you Noor, can you make sure that you installed the package which I am referring to? All right, so otherwise I just can put you in a room with. It's a warning. Okay, so if you put a warning, so that's we are doing it for just for the sake of the exercise, just to get our data in a format which we can put further in the tidy graph. So the idea is not really to calculate your correlations in the most accurate way, but just to demonstrate the use of packages. All right. So if it's just coming up with a warning rather than error, it's all good. You just move on, right? So now we've got.
Sorry, it's not even a warning. It's just that it's printed in red, and so you just all believe it's a warning or something. It's just saying that it's used Pearson correlations and treated missing observations in a certain way. That's all. Not
people, it's talking to you. It's talking to you, which is good.
Yes.
It's communication, interaction. All right. So so you've got, so we're not going into details of what is a correlation, why we do this, right? So if you are not familiar with what it is, just think about, so we are trying to isolate, so we've got members, so we've got those objects within our data set, and we're trying to see the connection. So how they're correlated, right? So some interaction. We just need this to be able to build our graph. Otherwise, we do have nodes, but we don't have edges, right? So this is for us to actually have those nodes and edges data so that we can create our table graph, right? So hopefully you are able to run the code, and how you can check that. So if you look under your environment, so if I look under my environment, it's over here. Oh, that environment is absolutely empty. That environment may be empty as well because I restarted my R. Yeah, that environment. So under in the environment, so if you run it, so under the environment over here, you should have this variable which where's that? So which says results of the correlation. All right. So rs.core, that's the object that we're going to use further. So this is the sort of data set that we're going to use further. Right. Right. So let's move further. Now let's have a look. Now, what we need to do, so this is like the part that we're interested in. So you remember, we're going through all these steps. So we don't really need to import our data because it's in built data set. We did some preparation, right? So we sort of played with that. And now this is where we're converting it to our table graph, right? So let's have a look. So I'm using, so this is my data set, results correlation, and I want it to be directed. So in this case, I'm using as table graph, and I'm converting it to my table graph object. All right. So correlation graph is the graph that you created. That graph includes two parts. It includes edges and includes nodes. All right. Before we go any further, again, so one of the key steps. So let's have a look what we did. So let's have a look how it looks for us. So you do ggraph. You set up your data layer. All right. So that's the first one. Now you add up your germ edge link. All right, so we, like in this case, we're just going without, like you see, it's very simple. We're just not really specifying any width or any color choices, just like simple. Can you just show it to us? All right, so if you remember, there was another cool function that we could use. So anybody remembers what was the function? We use it with Simpsons. So if we want, to get a really quick, like very quick look at the graph without really going into all the mess of setting up all the layers, you remember somebody was saying, it's a really good quotation. Get the autograph of the Simpson family, right? Yeah, so we can use autograph on that and get like the same thing, right? So get the autograph of your graph. All right, so a very simple way. This is just for you just to see what exactly you are getting. All right, so you're not really playing up with any of the options, but you just see like what exactly do you have it or do you not. All right, but again, so this is just, we're doing it for the sake of the example to show you that you specify those layers, but you need to specify all the parameters. So you don't really need to kill it. All right, you just need to go straightforward and just say, oh, well, this is my data layer. So data layer is absolutely a must. You need to have it. Now you need to add your edge link. So if you're not adding your edge link, you're not connecting your nodes. Right? So in this case, I'm saying, well, I'm adding my edges, whichever default option they have. And now have a look. I'm going with my nodes, and I'm also saying I don't. I'm not specifying anything, right? Just add my nodes. Can you just do that? Now, next one. So I want to see labels just to make sure that I actually have something to have a look there, right? So I'm adding germ node text. Right, and again, it's under aesthetics. So this is the part where it's so easy to messages because oh well, just brackets. Now, and this is the part where you have to specify, because otherwise it's, well, what's the point of just specifying the layer at all? So under aesthetics, you are saying for labels, can we use names? All right, so you can never go wrong with that. All right. Now you don't really have to specify your size though, but we're just doing it just so it stands out. All right, and then we're putting some like a very default theme. So let's do this. So basically you just need this part here. All right. Now, and then you talk to me. Look beautiful? How does it look? Not really, but yeah, so that's the bare minimum. Just for the sake of the exercise, I would try and run autograph and see how different that is. Just to give you a perception where you really need to put that many lines of your code compared to where you can go with just basic autograph. So for autograph, you just put autograph and then in brackets, you just use your object. Right? So let's have a look. So what do we see here? Let's have a look. So what exactly we're seeing here? All right. Can somebody talk to me so it's not myself talking to myself?
So 3 connected components.
Yeah, so we've got 3. So yeah, so you're quite right. So we've got, so what are those names? So these are the cars, right? So, and we are using, we are connecting them just based on the correlation matrix which we calculated, right? And we are looking at the connection between those cars. So we've got, yeah, so Sivan, you're saying we've got 3 components, right? So we've got 3 groups here. And, oh, well, somebody ran that autograph, right, and saying that they're coming up with very similar results, but without any names. So that just like shows you 1 line compared to like how many lines I'm getting here. Basically the same, right? Now, so let's have a look. So what are we going to do further? So in this case, so the most important thing here was to create that table graph, right? So like visualizing it, so it works. Now let's move further. So so if I try to pull it up, so have a look. So this is where it starts talking to me. So again, that's my correlation graph, right? So this is the table object. So we'll look at table graph. So we looked at iGraph object, we looked at StatNet object, now a network object. Now let's have a look at how explanatory is the notation for this one. So I'm just running that command, right? So run that one. Just pull up your object and let's have a look what it shows you. All right. So it's saying that you've got 24 nodes and you've got 59 edges. So we've done some manipulations earlier, right? And that's our node data, right? So that's our node data frame. So 24, so it's not showing you everything. And now you've got your edge data. So you're going to have a little bit more just because my screen is cut down, all right? But these are 2 data frames that you are going to use to do your further manipulations. So it's just like till that part, it's all straightforward, right? So you just created your table data. You are yet to see how we're going to apply all the tidyverse verbs to our object. Now, how far you're familiar with the dplyr? Dplyr is absolutely fantastic with data wrangling and data manipulation. Subsetting is a dream, right? Doing all the data wrangling is absolutely amazing there. So much simplified. When you can think about what do you do with the data, then how do I do this, right? So let's have a look what exactly we're going to do with this. As I told you, so we've got these 2 data frames, right? So we've got edges data frame and we've got a nodes data frame. Now, the whole idea behind table graph is that you can, like one of these 2 can be your active table, right? And you can switch. So that's the same thing as like you're putting spotlight on a speaker. That's the same thing as you can put a spotlight on a particular data frame. You have just a choice of 2, which will make it simpler, but you need to switch. So the data frame, which is on the focus now, which is activated or active data or active data frame, is the one that you're going to apply all the functions, right? So by default, your active data your active data frame is your nodes. So they think nodes are more important. So whichever, so if you don't do the activate function, by default it's going to do all operations on your nodes. Does that make sense? So nodes are active by default, If you need to change that, and we will be changing that in a second, you use the activate function. So you say activate, and then in brackets you include you include the other one, right? So you include edges, and then if I need to switch back, I say activate nodes, right? So as simple as that. Now let's look what I'm going to do. So I'm going to take, so you saw my graph, right? And you have yours. So this is my graph, right? So my nodes are activated by default. Now I'm going to activate my edges now. And what I'm going to do, I'm going to rearrange the rows in the in that edges table, right? So, and I'm going to say that I'm going to arrange them in a way that those with the highest R will be used first, all right? So let's have a look how I do that. right? So sounds easy, and it is easy when you're going to use diverse verbs. So let's have a look what we do. So we are taking our object, so our table graph. We are activating edges, just to say that we're going to work with edges now. Now the value that we have, so I have a look. So if we look at the edge data, so have a look what we have. All right, so that's our, what is this? That's our edge list, right? So we've got, all right, so we've got from nodes. So you remember that we created a directed one. So this is my edge going that way, and now that's my value. So I'm going to work with values for R now, and this is where I'm using one of the dplyr or tidyverse verbs, which is arrange. And so in arrange, take a parameter. So what exactly do you want to do? So how I want to arrange them, and I want to arrange them in a descending matter. So in descending order. So I'm using descending, and I'm specifying the parameter. So I'm going to use like R as the, like here, all right? So let's run that and let's have a look what we're going to get. All right. So this is a very simple example because like we don't really have any attributes other than that, right? So we just got the edge list, and this is it. But you can apply all the dplyr functions to whatever you want to do, right? So the most important thing is to remember that at this stage, the focus, so that spotlight is on your edges. So if you need to move it back and you need to do something with your nodes, you need to switch it back to your nodes. All right. Are we moving on? Sounds good. Now let's have a look. If any chance that you need to change it, to save it as a table, right? So you can convert it back to the table. So you can do that. So just say as table, and you use your correlation graph. So it's converted back to the table, right? And you can use like all the dplyr functions. So we can filter, we can arrange, we can add, rename, so like depending on like what sort of data you've got, and you can work with nodes data and you can work with edge data. So basically, like you may forget that you have a graph, and you may work with just data frames. So think about that as data frames. It makes life easier just because you don't really have to struggle about how you do things, but exactly what you want to do with them. So let's have a look what else we can do. So let's have a look and let's modify our nodes data, right? So what are we going to do here? So we're going to look at our cars, and we're going to group our cars by cylinder variable, all right? So now how many cylinders they have. So we're going to do that in our original data set, and then we're going to join our to add that data to our nodes data, all right? And then we're going to rename our names, and we're going to use labels, all right? So let's have a look. So why do we need to do that? Because our correlation table doesn't really have that extra information. So that's why we're going to get it from the original data set, and we're going to join it to our node, to our list, nodes data frame. So let's have a look. So we are looking at empty cars, right? And we're going to group them by cylinder variable, right? So that cylinder variable in this case, so you remember, so this is the case where you've got number and you need to convert numbers. So you need to treat number as a factor, right? Because other, like, it's not going to work otherwise. So let's do this. So we are creating, so what are we doing here? We are creating a data frame. And in this case, so we've got names, which will be row names. So all the, like, all the cars which we have in the data set. And for cylinder information, we're going to use it as a factor. Oops, let me copy it and post in the chat. Oops. Oh, come on. You know, you're in a hurry and you try to do things quicker. It always take twice as much time. Guys, just give me a second. I have no idea, but I think my keyboard is just gonna. Oh, wait, I cannot get it. Just give me a second because I'm just trying to. I think it's Zoom sort of hangs up on
Maria,
me.
Noor has pasted the first part.
Sorry?
Then Noor has copied, like, you know, typed the first part. Don't worry,
Perfect.
we'll get it done.
Yeah, well,
so
just
why
because
do you do that?
I have no idea, but for some reason, like, Zoom chat is hanging up for me, right? So I cannot do anything in the Zoom chat. So yeah, sorry about that, right? So guys, I cannot really help with this one, right? So, but yeah, so are you able to run that line? So we are creating that cars group data frame. There, yeah, it's back. Whew. So we're creating a cars group data frame. And now what we need to do, we need to, so have a look what we're doing. So we're going back to our correlation graph, right? So you remember, and on the previous step, we activated edges, all right? Now we need to switch it back to nodes. So if you don't activate your nodes, it's gonna come up with an error, all right? So you won't be able to do anything with that. So you need to activate your nodes and then have a look. So when your nodes activated, you can just forget about that H data frame like altogether, right? So for your, it just doesn't exist. So whatever manipulation you're doing, it is straightforward. So you just look at nodes, like, right? So that part is like, absolutely forget about that. So much simpler, right? So when we look at nodes, have a look what we're doing. We're doing the left join, right? So we don't really need to specify our nodes data set, which is in here already, but we're saying that we want to join our nodes with car groups, and we're joining them by names. All right, so we've got names in the, so if you go back to one of the previous slides, all right, so you've got your names over here. So this is what you're doing. So you're using names and you join on names, all right? And then so once it is joined, so you've got your names plus you've got your cylinder information. And once you've got your cylinder information, so what are we doing? We're renaming, and you no longer have names, you're going to have labels. All right, so can you run that? So again, so what are we doing? We're using the same object, so make sure that you run it only once. All right. Oh yeah, so guys, I'm just really stressing out in a hurry, trying to cover everything. All right, so this is a new data set. So this is a new data set, and now have a look. We've got names, right? So names are your nodes, and what do you think is going to happen with cylinders? So in classic terms, that will be your attributes, right? So that will be your attributes. And now let's look what we're going to do, right? So we are going to have a look at our edges, and we're going to rename edges to weights, all right? again, so this is a switching exercise. So have a look. We are so far we are on our nodes, and now we're switching it back to edges. So the most important thing, like where tidy graph makes it so simple to work with your graphs. The only thing that you always need to keep in mind, what is your current active data frame, right? Because you may have some errors if you're just on the wrong data frame. So activate edges, you don't have to deactivate anything. Whatever you activated, that will be your active one. So have a look, we're activating our edge list now. So our edge list, if you remember, so our edge list look like that, all right? I'm just renaming that bit here. So now I know it's all descending order, all right? So I rearranged that, and now I could do this in one go, right? I can do the renaming bit in the same step, but I'm just doing this for the sake to show you how I can switch between edges and nodes quite easily. So let me copy this. All right. So we're modifying this. So very easy, so much more straightforward. So that's why we didn't spend that much time on iGraph and StatNet, because tidy graph and ggraph makes your life with graphs so much easier. All right. So hopefully you are able to run it. And now let's look what our graph looks like now. All right. So run the table graph to see what you have. All right. So it's still same number of nodes, still same number of edges, but so your edge data. So if you look at your edge list, so you've got weights, so it's renamed, and that's your node data. So you've got your nodes as so you change the name to labels, and now that's your attribute. All right. Now, how are we doing? So I'm sort of like pacing it up, but I don't really want to have anyone lost, because this is a very cool feature. This is a very cool package that I would really encourage you to use, right? So this is the same as I would say, like comparing old like a data frame type of R with all the table and all the functionalities are available now in Tidyverse. So the minute you start Tidyverse, you probably would not really go back to all the classic R. And that's the same, I feel the same about graphs. So once you're starting using tidygraph and once you're starting using ggraph, it's very difficult to go back. That just autograph feature, it just kills it all right? So are we all good, doing good? So hopefully you are able to replicate those things. So now let's visualize those correlations. All right, so what do we need to do? So we change our edges. So we introduce that weight attribute, right? So which we're going to use. Now we are also going, just because if you look at the weight, it may not really be that easy to see on visual on a scale, right? So we're going to scale edges, the edge width, by setting our minimum width, right? So minimum width would be 0.2, and the maximum would be 1. So why we're doing this? Just because so that we're able to see this. Right, and now we're going to change the color of cars, the color of nodes, just because of that we've got the factor, a cylinder as a factor. Now, Norman is having an issue. Norman, it may be that you so if you go back, so you need to make sure that you are doing everything in succession, just because if you renamed it, you remember we renamed name to label, and that's what I'm saying, just because you're referring to the same correlation graph. So what I would suggest, can you just learn just in your console, can you just type this, all right, so correlation graph, and have a look, because most likely you already done that step and you're trying to join them again because you already renamed your names into labels. That's why if you've got your labels now, you won't be able to join them. Does that make sense? So when your eye is talking to you, it's saying that you don't really have name as a variable in your data set. So like the only way of how I can think about that is just because you already ran that line and that you're trying to redo that. All right, but let's have a look how we can visualize that. All right, so we're going to do a little more on this. All right, just let's make our graph. So you remember the picture which we started with, it looks like very grayish, right? So not really that exciting. So now let's have a look at how we can visualize our correlations using the G graph. Right? Yep. Thank you, Savanti. So let's have a look. So again, G graph. So what are we doing with G graph? So we're trying to, so we're putting a bit more options here, and this is because we're trying to actually make use of all the changes which we've done to our graph object. So we have G graph, that's the first layer. So the data layer, we're setting it up. Now we're adding up our edges. Now with the edges, we're saying that, so you see with the width of the edge, we are relating it back to the weight attribute, right? Again, make sure that you include your aesthetics. Most people would just not use that, and they will get an error. So aesthetics, and then in brackets, again, why aesthetics? Because it comes from the data. Whatever comes from the data frame, or whichever data frame you're using, as long as it is from the data, it needs to go under mapping. So it needs to go under aesthetics. So alpha, we're setting transparency. So that germ edge link has to be there, right? Now this is where we're scaling. So we haven't touched scaling, but this is one of the area that you, so it's another layer that we're introducing that you can use. So we're scaling edge width, and that's what we're saying. So we want it to be between, and we're specifying it as a vector here. All right, now we're adding the next layer, and that next layer is a germ node point. So what we're doing here, we're specifying, so we're using a cylinder as a factor, and we're assigning it to color. So if you look at my legend, and in here I do use the legend. So I'm saying that I do have 3 different categories for my cylinder factor, 4, 6, and 8. And you remember I mentioned that you need to put it as a factor, because otherwise it will be taking as a number, right? So it's coming from the data set. So I'm just putting aesthetics there, and I'm putting my size to 2. Right now, so this is like the actual points, and now on my next line, so I'm adding another layer here, and I'm referencing my labels. So labels come from data, so again I'm referencing my aesthetics. So again, make sure it's only the part which sort of comes under from your data is referenced here, so everything else is outside brackets. So I do have my size, right? And I'm just applying the common thing. All right, so are we all done with this? Let me do like one little thing. So that example and then I will move on to the Twitter data, which I promised to a couple of people to talk about. If we don't have time to answer all the questions about that Twitter data collection, I'm very happy to just to communicate via emails. Right, so I struggle with that a lot myself, so I do understand all the concerns and agility around the issue. All right. So, Sivandi, what do you think? Just go with centrality? Tidy graph has quite a few measures of how they can calculate centrality. I was not really just going through details of that centrality measure before, because I was hoping that we can get into that as we go through now. But just for your reference, so Tidy graph has quite a few inbuilt centrality measures that you can use, apart from the ones which we've covered. So different ways how this can be calculated. We'll look at the ways how you can select the best centrality measures, and these are some options that Tidy graph gives it to you. Now, the beauty of using Tidy graph centrality measures here is that, have a look. So what are we going to do? So you can when you use those classic examples, those classic packages, they may not be that straightforward to use in a dplyr world, right? So here we're back to so I'm just going to talk about that, and then you have your slides so you can run through all these examples. So we're back to so with the beauty of using inbuilt functions in your Tidy graph is just because you can use those functions in your dplyr. So here, so we're back to our phone net data set. So what are we doing? We're activating our nodes, and have a look what I'm doing. I'm using my mutate. So do you remember in a classic iGraph example, in a classic StatNet example, you can add your attributes, but that was quite a few steps that you have to do, right? In here, so you don't have to worry about like, oh, what's the notation for that package, which package I'm using, right? So in this case, it's just as straightforward as you're using mutate, which is a normal verb dplyr function to create a variable. So you create a variable and you call it centrality, and you just include the function, and you don't have to worry about, oh, is it an attribute? So what do I do? How is, like, what's the syntax? It's just as straightforward. You just look at in your world. So in the world of the Tidy graph, it's just another variable that you add to your nodes data set, right? So, and so like you see, like we're creating it in this step, and in the next step, we're piping it through to our gggraph, right? Same layout, but now have a look. When we look at the size of our points, we're just linking it under aesthetics. So we're linking color and size to centrality, and this is like easy done. So it takes so much of your efforts away from thinking about how to use packages in terms of like how exactly you work with the data. So I think this is, so I also have the clustering example. So for clustering, again, I'm not going to go into too much details in here, just because clustering is just a very big topic on its own. So it's just like to show you why Tidy graph is easier to use and is, I would say, more user-friendly. So they do have quite a few of the clustering algorithms inbuilt in the Tidy graph package. Now, these are the tools that we'll be using in my example. So group infomap, right? So it's again, so it's a classic example. right? So it's a classic example of using community finding. And now, and you've got group edge betweenness, right? So you look into identifying community structures just based on those edge betweenness measure, right? It just, again, so like I'm not going into details of how this is done, but I'm just going to show you how this is demonstrated over here, right? So let's have a look. So this is, again, so have a look. The most tricky bits is just to make sure that you are on the right data frame. So I'm activating my nodes, all right, and I'm going to basically cluster my nodes. So I'm using group info map function. You can use whatever function suits you better, right? But again, so from the point of the graph, it's just like creating another variable for the graph. And now let's have a look. So that's changed. So I'm linking my color back to the community variable, which is the attribute for my nodes, which I created, and it's linked there. So very easy, right? So very easy, so much easier than to do with a tidy graph. So that's perfect, right? So I think this is it. So like the whole presentation will be available definitely. So I suggest that you actually have your hands on that example. Oh, like me, Zoom is playing up big time. It doesn't pull up things, right? So have a look at those example, around those example, and I really encourage you. So that iGraph package and StatNet, they are massive. They're classic packages. They do have a lot of things to offer, but in terms of user friendliness and how you do those things in terms of the workflow, so tidygraph suggests quite a nice workflow. So it's everything is still compatible with all the classic packages. It's just like an easy way, more user-friendly way of doing this, right? So if you've got any issues, we may not really have enough time to go through all of them, but I'm all reachable by email. We're going to send out a slides link to the actual slides, and all additional information. Couple of people asked me about some other ideas, some other packages available. So dynamic networks. I'm going to reply to all the emails and then share whatever knowledge I've got, right? So it's not like just like we're saying goodbye. We're saying hello to tidygraph, ggraph, and all the exciting world of using R for network science, right? Now, Savandi, what do you think if we just touch base a little bit on the Twitter case and how we work with Twitter? And again, so if we are moving on, because we've got our next engagement, so we've got next item on our agenda at 3:15, so we have to move on. I'm happy to stay in the breakout room and share all the possible knowledge that I have around collecting data from social media. How it feels.
Yes, so we can make a breakout room from 3:15 to 3:30, I think. But when 3:30, we need to kind of close the breakout room. But Marie, you've done a fabulous job with the hands-on session. Honestly, it's a lot of massive amount of work. I'm sure people who stayed for both days would agree. It is a massive, and I saw Daniel, I think, saying that before the lunch break as well. Thank you so much.
You're welcome. Thank you.
It's
hopefully you've got, so hopefully you are all engaged in using tidygraph and gggraph, right? So R has a lot of things to offer, and though people say, oh well, we do have that standalone desktop applications where we can use like other software, and with R you do have your learning curve, but it's so much worth it. It has so much to offer, and eventually, it's just like as you try to walk, so you bump a couple of times, right? So if you've got all your, like, how do I do this, how I do this, but once you get a grasp of like packages, you will be amazed how easy and how flexible your life with network science will be. So much to offer. But again, so many other issues that are yet to be researched and that yet is growing. So R has a very dynamic community and very supportive community. And again, so this is unfortunate. We are yet to cover, so we haven't covered all the resources available, but it's such a massive growing area, and network science is such a big growing. So with the demand in a sense, in the academic community, and not so much in the academic community, but also in the industry. So lots of people interested in applying that. It's growing. All right. So again, I'm very interested in to see how people go and if they've got any issues. Unfortunately, we didn't have time to practice that last bit. So if you have any issues with that, or if you need some resources, again, I'm very passionate about just covering more topics in network science. Unfortunately, we didn't have time to cover all of this. It's a growing area, but it's a lot to cover. So if you want to start that conversation on the emails, all right, how to use what are the packages available, how do you do particular things, and again with social media, I've been struggling with that, struggling not with the social media itself, but with all the game-changing rules of social media platforms. All the methodology is there, but data may not be. And the problem is that all the social media platforms are particular about changing rules. And it's like, you think about that, it's a war, right? They change rules overnight, they don't tell you. And the perfect script, so the perfect cron job that you've got running and collecting your data, suddenly not working. So you have to spend, I remember that was just before user R. So I've got all my tutorials set up perfectly, right? Just working with APIs and everything. And, overnight, just 2 weeks before the conference, they just changed their APIs and they just changed everything. And I was struggling. Oh, well, I just tried my script. It's not working. What's happening? Nothing announced, nothing say, rules change. Whoever is the owner set the rules. So this is the biggest problem with all the social media research. They change rules and data may not be available. So with all the ethical implications, so we are academic researchers and we're usually quite ethical in terms of what we're doing. So we are using anonymous data, but sometimes they they use you as a scapegoat. So let's kill academic research. All right. But so with good things. So I've got two things, 2 minutes to go. So really good news for all Twitter researchers. So, and again, doesn't matter if you're coming to the breakout rooms or not. So let me show you. Good thing about Twitter is that last month Twitter started allowing academic use of their data. So that's my biggest news to everyone. So now, as an academic researcher, you can apply for academic access, and you can have access to historical data. So it used to be only just very limited, one week time of tweets. Now you can get it all. So big news for all of you. All right. So at this stage, so I want to thank you all for coming these 2 days. So you survived. Hopefully you enjoyed, and hopefully you got something for you to take and just to use. Right? We've got a very diverse cohort. So people coming from all the different backgrounds. People coming from all the just all the areas, all industries, all different level of skills, right? But we managed that. So thank you all for coming. It was really a pleasure to have you all here, and hopefully I can share some other knowledge later in the breakout room and via email. Thank you.